A 2-day workshop on unified airspace management and allied technologies was organized on 17th and 18th July 2025 by CSIR National Aerospace Laboratories NAL at National Physical Laboratory, New Delhi. National Aerospace Laboratories is an aerospace research institute in India established by the Council of Scientific and Industrial Research CSIR in Delhi in 1959. Many eminent personalities and dignitaries participated in this workshop.
We are privileged to have with us a distinguished panel of guests and speakers who have played instrumental roles in advancing India's capabilities in science, technology, and aerospace innovation. It is with great joy and gratitude that we welcome each one of you to this visual workshop on unified airspace management and allied technologies. As we embark on this enlightening journey of knowledge and collaboration, it is customary to begin on an auspicious note. The lighting of the lamp symbolizes the dispelling of darkness and the ushering in of wisdom and positivity.
Dr. Abhay A. Pashilkar, Director, CSIR-NAL, in his welcome address said,
"The word signifies the fact that we have to unify so many things, whether it's communication, whether it's navigation, whether it's airspace management, and ultimately the vehicles, which we are also much eager to design and develop to create this ecosystem. So it really requires all of these entities to come together, and I'm really glad that all of them have readily agreed, despite their very busy schedule, to be here with us and to roll out this particular initiative of CSIR, in which we have great hopes that we will be able to contribute scientifically and technically to many of these areas. We have 37 laboratories within CSIR, and we are right now at the NPL, which is responsible for holding all the standards in this country. We have ourselves, we are from the aerospace lab. We have labs which are working in embedded systems. We have labs which are working in instrumentation. So all of the engineering labs, I believe, come together to realize this endeavor that we have to deliver something which is in the line of Atmanirbhar Bharat.
Dr. Hanumanth Rao, Director General, Society for Applied Microwave Electronics Engineering and Research, Samir, Ministry of Electronics and Information Technology, Government of India.
The standards are evolving into bring the entire this non-terrestrial network into reality. Till now, we're looking only drones are being flown and UAVs flown with licenses. Finally, it comes to a stage where it will be flooded. The way you have the number of vehicles on the terrestrial, on the ground, suppose it need to happen there in the space, then the technologies which enable the entire non-terrestrial networks is going to be very, very critical. All the solutions which have been done on the terrestrial, especially up to 5G, we don't have the non-terrestrial network directed to between the cell to the multiple long distance. We still use the satellite links, but all the network within the deployment area, it's morely terrestrial. So only the one term which is coming as major change from the way from 4G to 5G, we have connected things. So till now we had connected people up to 4G, then 5G became connected things. You start talking about vehicle communication, IoT devices, and multiple sensors integrated and fused into one. But still everything happened on the terrestrial. 6G is one of the areas which they're talking about, keeping on same way of doing the research, continuing the large bandwidths and the data rates and low latencies and other applications. One feature which is coming very predominantly, strongly being looked at the standards bodies is the non-terrestrial network. And it doesn't talk only the satellites. When say non-terrestrial, anything above the ground. We have the high altitude platforms, we have UAVs, we have drones, and we have the balloons when we kept them. And over and above, we have LEO, MEO, and GEO satellites there. So that is really the research which is happening in that area is mind-blowing. The way if you look at the ground-based solution, we have base station is station, the only user is moving. So it's kind of different kind of a protocol, different kind of a deployment scenario. The minute it becomes non-terrestrial network, especially LEO satellites, automatically the user is moving and both points are moving. Compensating for that kind of a motion is another challenge. And of the distances, the travel and the losses which are involved there from the satellite to the or high altitude platform to the cellular phone or maybe the ground station, they are going to be completely different the way it has been network is visualized. So these are the certain things which are going to be very, very challenging. Few areas which which probably I just keep it open for the researchers across CSR lab, of course other people who have been participating them. The devices is the one which is going to create the trouble. The devices, especially the high power devices where we need the gallium nitride amplifiers, or doing the devices at higher frequencies for using gas or CMOS or bi-CMOS, indium phosphide. These are the technologies still going to put us in trouble. So that's the one place where there's a lot of more research happens. Second thing is the kind of the antennas in packages. You have very tiny device sitting there in the space and it has to substitute your base station. It has to what we call as a G-node beam. It has to replace the ground-based G-node beam, has to be converted into very tiny, lightweight and flying on a platform and maintain the same protocols and expect it to deliver more amount of data on the energy and the power. So there the place of antennas in packages comes into picture in addition to the devices. The network topologies are completely different there, as I mentioned. So including the Dopplers which are going to come there because of the motion. The way you might have heard so much of a Starlink. Starlink, when it operates, you understand it operates from the ground antenna is a beam steering antenna. It has to track to the satellite continuously. Then satellite goes out of the range, track to the next satellite. So still that's not been envisaged that if non-terrestrial network has to happen on the ground. The way we look at the geostation satellite, we have the footprint. We have the contour, it covers the entire country. Whether that kind of model comes or we have the multiple beams are coming from the high altitude platforms or dedicated beams for the data, dedicated beam for communication, dedicated beams for the disaster management. These are certain interesting areas which needs a lot of research and happening across the globe, across the universities also. That's one area probably I request most of the researchers look at it on the technology side. And as usual, coming back to the basic equipment, which is your drone or your high altitude platform, the materials. Materials going to continue to be changed. Forever is going to be a challenge in India. Lightweight. Same time, most of these electronic systems need a ground plane. And hardly we get any ground plane because there's no metal sitting on top of the drone. So these are another challenge which come there, how to compromise the computer composites which has lightweight, at the same time give the required, the kind of a ground plane and kind of a deployment environment for the electronic systems which are going to sit on top of it. The other one thing. And the third one is endurance. Somebody is building on the drones or maybe the UAVs, the endurance of it and how far it can fly continuously. And at the same time, maintaining its, some are dedicated ones, some are rogue drones, some are friendly drones. Now there's a kind of a next level. We are not gone to the point that the way like aircraft flies, we know IFF, we have friend and foe. We are not gone into any of the high altitude platforms to identify it. Only we have the data with us and we scan it and say that we would identify and classify them as a friend or foe. We don't have the IFF sitting there from drone. We are not gone. The swarm of 1,000 drones coming there. You don't have the established the link. These are things which are going to come. It becomes a solution. Till now it is going to be a kind of a war scenario. It could be a kind of a trials which are for the delivery of the goods or something which are being done, or maybe the what we call as a air ambulance. Some of things which are being tried. These are dedicated channels are given, dedicated roadways are given to you. If they have simultaneously to be deployed, now you need to have out of 1,000 drones flying over the head. As per the security measures, you need to understand how many are there. Authorized drones, unauthorized drones. I mean, a drone means UAV, what are the name? You can have altitude platforms there which are in motion and how to bring it down. So there's one technology which comes about this, the counter drone systems. There are multiple ways. There's a huge setup, the fusion of the systems, where the tracking, as I said, identification and sensing and identification and classification, then the jamming. And then the jamming, we have the hard kill and the soft kill. We can spoof the GPS. Fortunately, we'll have our own Navic chips may get onto the what have been deployed in India. We'll have the completely our own GPS system there, not depending on the external GPS. That adds extra security layers to us. We know that it's going to be our drone. So then spoofing on the software side or breaking the link between drone and ground links, data links. Hard kill is probably can have the laser or electromagnetic high energy weapons.
Dr. N. Kalaiselvi, Secretary, DSIR and DG-CSIR, in her presidential address said,
When NAL is working on and when we are proudly talking about that we are indigenizing different components of Tejas, now we have with us today the pilot of Tejas, and therefore I think this is the best way that workshop can be arranged where somebody has really taken the complete control of one particular aircraft and the other one who is really trying to indigenize it from the research point of view. When it comes to the Secretary of MOCA, I think CSIR is always finding lot of more support from almost every secretary, and a special mention has to be made with respect to MOCA, because recently when we just announced our partner, the production partner for our two-seater aircraft Hansa NG, at that time also present Secretary DOE Dr. Mr. Valnamji, he was the Secretary MOCA and he was there, and even the Minister of MOCA was also there along with our minister, and this is how always MOCA and CSIR, we always travel together. Now, when we are not able to even arrive at a kind of a convincing conclusion and a convincing management with respect to our even road traffic, now we are forced to think air traffic also also in a much more serious manner, that is the biggest challenge. So you people should definitely now understand. So whatever we talked on roadside, so we had started with two-wheeler, three-wheeler, four-wheeler, then we said that conventional fuels, then we started about e-fuels, we started about e-mobility, now we talked about air mobility. Then in air mobility, again we have number of, I would say, vehicles. So once we had only aircrafts, then they said it is not only aircrafts, there are helicopters. Then we understood, okay, helicopters. Now they say drones. Now he is telling friend and foe drone also. Okay, drones are there. Now we are talking about number of unmanned aerial vehicles, and in between we have the HAPS also. This is a high altitude pseudo platform also. So he will also be somewhere roaming there, hanging there, and we have to really have some kind of an agreement, some kind of unwritten MOA, some kind of friendship by means of which we have to make the air traffic to go in a very perfect manner. And this sustainable air management and air mobility, it requires lot of help from the AI world especially. So we have to now get lot of data. One is data collection, and the second one is this blockchain based data communication, and the third one is AI based decision making, and above all these things should definitely give you the safety and security end of the day, and everything should be controlled by a real control room or a virtual control room, manned vehicle, unmanned aerial vehicle. All these points you have to arrive at a solution, and therefore friends, we are here to just help you in getting known about these challenges, and also we are not going to leave you as such just by listing out these are the challenges. That is why we have the galaxy of leaders here, and galaxy of speakers are also going to join you from time to time. They will tell you, don't get worried about all these challenges. We are here to help you, educate you, handhold you, handshake you, and to travel with you, by means of which we as a team can definitely see that this sustainable and unified aircraft management and air traffic management is best taken care of in the Indian scenario. This workshop is going to give a very good confidence that this synergy is going to give a very big profit in the coming times.
Guest of honor Dr. S. Somanath, former Secretary, Department of Space and former Chairman, ISRO.
I think this workshop has different elements. The first and foremost is technologies and domains, which will vary. I think when you talk about aircrafts management, this also, historically it evolved over a period of time of various types of platforms. I think we have now globally certain standards in which aircraft are controlled, but possibly this is also not the strategic component as well as a civilian component. We know that in aircrafts also there is differentiated, though there is an understanding that they are unified. So we need to understand this differentiated, unified concept in this as well. It will come because we can't unify everything. We need to keep them at certain distance away, but we need to find a way to unify. Those unification will happen in certain domains. It won't happen in certain other domains. I think this is very important to understand that apply. Again, on this unmanned vehicle, we call them unmanned aerial vehicles, but then slowly they are going to become manned as well. And we know that very clearly, that especially when you talk about drones being used for personal transport, and this is going to be a major game changer in the areas of unmanned vehicle now becoming manned vehicles. And then the question of personal safety regulation becomes much more stricter than those drones that are used for agriculture, disaster management, and many other, even for defense, it's not going to be manned at all. So they are of one class, and the one which will have people traveling will be of different class. I think you are aware of many people within the country developing such drones like scooters and cars where people will be traveling for short distance holds, possibly from cities to airports and back and forth, typically 30 to 50 kilometers of journey. And this is going to be the one which need to be addressed at the very first instant. Then all those vehicles which are going to be under the consideration of this regulation or governance. So this requires so much of attention at this moment because many of them are going to be a reality in a few months, I believe, may not be many years away. And that's very much visible in front of them. And many of the regulators, policymakers, technocrats will be faced with the challenge of how do we really start it? I think the starting is going to be very problematic, and I'm very sure about it. Possibly they may do some demonstration, but then converting into an operational system where industries come and operators come, they will operate on a commercial basis is simply going to be a huge challenge to start with itself. In next 1 or 2 years, we need to do that. So my request is that let us address that sector immediately and find a way by which we can actually start it. The second, then it will happen that when the human traveling drones come into action along with other platforms, we need to worry about the autonomous drones which are also going to occupy the same space, possibly becoming a threat to many of such transportation. So then we need to now look at creating another set of norms where the manned and unmanned vehicles coexist in the same airspace, and how do you really really deal with that situation. Now here the next set of scaling up of the whole plans, we need to address it. Possibly this is little next second phase, and that also need to be addressed. Many of us know, I think all of you most probably know, that this domain is very technology centric, and one of the important issue is communication, of course, than many other things which of course they need to be addressed, like safety, the corridor definitions, the people who are really going to manage, who are the one who need to know about it. I think many of these things will come in discussion. But the elements of technology that will enable us to do unified airspace management is the first thing. In that, the communication becomes the key element. Defining standards and the participating entities become important. Of course, the vehicles themselves are the ones, but who are the other people who are going to be part of this? Let me discuss with you whether the terrestrial networks, possibly the towers that we know, will it be ever part of this whole network? Standard 5G, 6G networks which are going to be there around us, will they be the one which will become part of it, or something else that we will put? There will be a separate set of network than the one which is currently handling mobile network. The second question is whether you will put additional set of platforms like the one which will be floating above us and which will handle all of this, for specifically designed for this, will be the one we have to ensure there are no clashes, there are no issues. Then the third layer, of course, is the spacecrafts, and how spacecrafts can really become part of this whole aircraft navigation, whether it is really technically feasible, reliable, and available, because availability becomes very important all the time. Whether this is going to be a technology which will enable us to do that way, looking at the operational time criticalities as well. Now, I coming from space sector, and we have been discussing, knowing about this opportunity coming in space. Of course, we are all aware that space can do only three things. One, it can do communication backbone support. It can also do imaging. Of course, it can give the navigation timing support. So how do you really integrate this into different set of satellites, or you really bring in a common system or architecture which can be really enabled for unified airspace management? And globally, this is also going through a huge amount of changes in the recent times. The communication is also changing. That it has been generally through geo platforms. Now LEO platforms are taking over across the world, and now Starlink is also coming to India, and slowly you will see that you will have direct to device connectivity from low altitude and medium altitude orbiting satellites. You will have a direct mobile connectivity with not much of time related issues coming up in the real time communication. Now, when such a global presence of a communication network is present, which is more available and reliable, do we need to put anything else? The question of out of line of sight, because when aircrafts requires a line of sight communication capability, here the line of sight is not really going to be possible, and many a times that you will never be able to see that. You cannot track it from such places. The type of technologies which are required, and how do you really identify objects which are flying? Whether you need to use imaging technologies to identify and track, like object identification tracking through high resolution imaging, whether it requires to be done, you add another layer of safety into the identification so that you will be able to navigate just not based on communication alone or positioning it based on such signals alone. So this, whether we need to have multi-sensor fusion capability to positively assure availability or position of any object flying. So this becomes a major issue. Then the issue, like for example, cities where the human beings are going to fly from some buildings to airport, for example. The corridors are to be defined. I think these are the corridors that we need to urgently define, and along the corridors we need to make sure that it is fully visible, traceable throughout the journey from one place to another. In such a journey, whether we are going to create any separate architecture of communication networks through available mobile towers, or you are going to use some buildings, you are going to use some extra communication architecture along the path which are well defined, so that you are not allowed to deviate or you are not allowed to cross any such places. So this also calls for large scale investment in terms of infrastructure investment, and also roles and responsibilities of who the investors are, how you really take returns of it, and who are the custodians of all of this. This becomes another topic of discussion, whether it is a civilian authority, not just the regulators, I mean operators of this becomes important, and how do you really bring out the returns from this, and who are going to pay for it. All this becomes a commercial activity which also need to be addressed. Of course, in India, I think this is slowly growing, emerging, especially the unmanned aerial vehicle sector. I'm not going to the strategic and defense side, because I asked in the beginning, I said that this is going to be coexisting, working, but it has to be treated in a different manner. For example, as a director, Samir just mentioned, when you look at swarms and strategic cases, possibly all of these are likely to fail, and you may not be able to operate with that type of environment, and it has to be handled in a totally different architecture, I believe. But then it will become important issue for us in other domains. For example, disaster management. When you need to look at disaster, all of us know that drones are going to play more and more important roles in the days to come. For example, distribution of food, distribution of medicines, kits, scanning and understanding the situations around, and then reporting back. I think drones will become bigger role when they play, and there are large number of drones need need to be deployed or crafts need to be deployed at that point in time. In such occasions, how do you really create local emergent basis networks? Possibly it won't be existing at that point in time before the disaster occurred, and we need to create in very short notice such conditions for somewhere. How do you really create such local regulation capability? For example, on a hill, generally nobody will be going, but then there is a need to go. But then still you need to operate at large drones. And this is another new case. How do we need to define? And can we really create a space-based networks at a local region using this is another interesting questions which need to be addressed. Another domain is called smart cities. I think smart cities again emerging. So it is possible to envision creating such infrastructure as integral part of this. And how do you right now itself bring policies or principles by which smart cities need to address this particular issue right at the beginning of discussion itself. Now, what all things we need to do? I think today after the workshop, possibly some certain steps that we need to be taking, discussion need to happen on many things. I think that's what is meant out of a workshop, I believe. All those stakeholders should take action on some of these points, which I think is very important. For example, the point I mentioned, which are the domains that we need to take up immediately, where certain actions can be taken. I believe it is where the human travel in such platforms are going to happen, especially at crowded cities where they are likely to be deployed on a commercial basis. And this requires very important actions in terms of identification of corridors, areas where it can be applied, and then create norms for it to operate, and then create infrastructure for it to operate. This is the first step. Second, of course, is any of such things requires test beds, certification processes. I think these steps will be taken definitely by NAL and other stakeholders in this, and that actions are now being taken by NAL, and this will become very important resource for people to come and then develop and then prove that this will really work. It is not possible to have with one test bed. I am sure about it. There are so many developers and so many operators, and we need to have multiple test beds and places in the country, across the country, for this to really scale up. Third is skilling. People are going to be very important. Who are the people who are going to operate it? What are the protocols that will come into place? Who are the knowledgeable people? And we need to first create courses, curricula of how do we really do that in this domain. And this again becomes an academic industry collaboration domain. Skilling and developing people to handle it is going to be the third domain. Of course, as we discussed, is technology domain, the part which will be done in terms of communication, in terms of safety. It's again going to be a very important issue for most of the vehicle going to operate here. How do you address the safety of many of these vehicles and certify it from the safety point of view? For example, in case of failure, what to do next in these vehicles becomes an important aspect. Where do you really go and land? How do you further navigate it in terms of autonomous systems fail and how manual interventions are done? This becomes a very serious issue to address in terms of such vehicles, because even with all of this, if there is a rogue activity, then you will be in trouble, even with a good fellows working system. So technologies become important. Indigenization become important, because many of this, the initial steps will always be based on somebody developed and purchased and installed. I think that should not be the way. I think the very beginning itself, we must make sure that the whole of the corresponding technologies, including software, protocols, hardware that will be deployed across the country, training, everything is actually based on techs developed within the country. And we need to insist and create principles by which it will be only remaining to be indigenous. And finally, customers, businesses. I think this also, anything that you want to do in this domain will be also linked with such activity, and it will never be possible from governments alone or institutions alone to drive it. We need to find out who are actually going to use it, who are actually going to fund it, where the money will come from. The business processes also should be discussed. And unless that is there will not be a huge amount of investment coming and creating infrastructure for it. That process is very important, and who is going to take leadership for it? This is again another topic. And finally, it's important that we need to connect people who will be creating this capability in research institutions and academics, etc. They will also should be part of this whole process, where they will work with all the stakeholders, policymakers to create the next steps. So I believe these are the few steps that we need to take beyond this workshop. And if you are able to identify and then take the next steps and expand this work in the coming years, I think we are in the right path.
Chief Guest Shri Samir Kumar Sinha, Secretary, Ministry of Civil Aviation.
India is now among the fastest growing aviation markets in the world, with over hundreds of airports and airstrips, expanding air traffic and rising connectivity. We are well on the path to becoming a global aviation leader. Alongside this traditional growth, we are also seeing a sharp rise in drone activity in agriculture, logistics, mapping, surveillance, and emergency response. responses. Nearly 20 central government departments and many state governments are actively using drones, and the skies, therefore, we can conclude above us are changing and changing very fast. We are entering an era where drones, air taxis, and unmanned aerial vehicles will share airspace with commercial aircraft and defense operations. And this transformation demands a fresh look at how we manage and govern our airspace. And that is why this workshop becomes very, very important. I would like to state that today's airspace is multi-layered and multi-stakeholder. Scheduled flights, military aircrafts, helicopters, UAVs, and eVTOL will increasingly operate in shared zones. And this calls for a unified airspace management system, one that enables safe, real-time coordination between all types of aerial platforms, both manned and unmanned. And such a system must be built on digital approvals, automated deconfliction, geofencing, real-time tracking, and seamless integration between unmanned traffic management and our existing air traffic management, mostly managed by Airport Authority of India. Urban air mobility is no longer a concept for the future. The arrival of eVTOLs and air taxis will introduce low-altitude, high-frequency operations in densely populated areas. Managing noise, safety, corridors, and emergency response will be very, very critical going forward. We are already seeing interest from Indian enterprises. For instance, Interglobe Enterprise has placed an order for 200 eVTOLs, a signal of what is coming. To make this a success, we must modernize our infrastructure, reimagine policy, and ensure public trust through safety and through transparency. Transparent procedures are must for anything to succeed in this realm. I would like to highlight very briefly though policy enablers and government initiatives, and of course we have a long way to go in this regard. At the Ministry of Civil Aviation, we have taken a series of forward-looking steps to support the evolution. The drone rules we all know of 2021 replaced a restrictive regime with a liberalized trust-based framework. Unnecessary approvals were removed. Digital sky became the backbone of seamless permissions. Payload limits were expanded and foreign participation made easier. On PLI schemes for drones, which was launched, under this scheme, over 20 drone manufacturers have already qualified. This is generating employment, investment, and innovation. We are in the process of expanding this in months ahead. On national airspace mapping, I would like to say that India's low-altitude airspace has been digitally segmented into green, yellow, and red zones, as we know, allowing for safe, autonomous operations and better planning. On integration of UTM and ATM, another key area we are working closely with Director General of Civil Aviation, Airport Authority of India, and defense agencies to integrate UTM into our ATM infrastructure. This is a foundational step for unified oversight. On the importance of subject of civil-military coordination and also cooperation, we are progressing toward flexible use of airspace, where civil and military authorities share dynamic awareness as seen in leading global models. Another key area, the area of command and control framework, is also very, very crucial, very critical and important. An integrated platform is being developed for real-time situational awareness, supporting faster responses and better coordination across agencies. DG-CSIR has already highlighted the role of collaboration of different agencies coming to at one platform. And here I would like to say that this vision cannot be realized by government alone. I am happy to note that all relevant agencies are part of this important 2 days workshop. We need mission mode partnerships across the ecosystem. Could be with MOCA and CSIR, DG-CSIR and startups, defense services and academia, public and private UTM providers. We must also invest in certification bodies, testing infrastructure, simulation test beds, and capacity building for regulators and operators alike. I would now like to briefly touch upon our national vision, Viksit Bharat 2047. As we chart this journey, we must align with the broader vision of Viksit Bharat 2047, develop inclusive and innovation-driven India by our 100th year of independence. Modernizing our airspace is not just a technical goal, it is a national mission to ensure faster, safer, and more inclusive mobility, especially for our growing urban centers and remote areas. Workshops like this are where visions become actionable roadmaps. I urge all participants to use these discussions to develop actionable, forward-looking solutions. On behalf of the Ministry of Civil Aviation, I assure you that we stand ready to facilitate, cooperate, regulate, and lead India's transition to a unified, intelligent, and inclusive airspace architecture. Let us just not adapt to the future, let us lead and define it.
Vote of thanks was presented by Dr. P. Lata Shri, Chief Scientist, CSIR-NAL.
It's my privilege to deliver the vote of thanks on behalf of CSIR-NAL and CSIR-NPL at this thought-provoking inaugural session of the two-day workshop on Unified Airspace Management and Allied Technologies. CSIR's multidisciplinary capabilities across aerospace, electronics, computing and materials science shall transform the urban air mobility endeavor of CSIR into a reality. I would like to extend my warm thanks to directors of CSIR-NAL and CSIR-NPL for their unconditional support. Director CSIR-NAL has in nutshell brought out the objective of this Unified Airspace Management workshop, which is a need of the hour.
National Aerospace Laboratories closely operates with HAL, DRDO and ISRO and has the prime responsibility of developing civilian aircraft in India. Narrated by Priyanka, Kumari and produced by Dilip Jha. This broadcast came to you from Indraprasth channel of Akashvani, Delhi.